AWS Certified DevOps Engineer. Professional DOP-C02 dumps are newly cracked to help you pass your exam easily. 1. A company has its AWS accounts in an organization in AWS organizations. AWS config is manually configured in each AWS account. The company needs to implement a solution to centrally configure AWS config for all accounts in the organization. The solution also must record resource changes to a central account. Which combination of actions should a DevOps engineer perform to meet these requirements? Choose 2. A. Configure a delegated administrator account for AWS config. Enable trusted access for AWS config in the organization. B. Configure a delegated administrator account for AWS config. Create a service-linked role for AWS config in the organization's management account. C. Create an AWS CloudFormation template to create an AWS config aggregator. Configure a CloudFormation stack set to deploy the template to all accounts in the organization. D. Create an AWS config organization aggregator in the organization's management account. Configure data collection from all AWS accounts in the organization and from all AWS regions. E. Create an AWS config organization aggregator in the delegated administrator account. Configure data collection from all AWS accounts in the organization and from all AWS regions. 2. A company provides an application to customers. The application has an Amazon API Gateway REST API that invokes an AWS Lambda function. On initialization, the Lambda function loads a large amount of data from an Amazon DynamoDB table. The data load process results in long cold start times of 8 to 10 seconds. The DynamoDB table has DynamoDB Accelerator (DAX) configured. Customers report that the application intermittently takes a long time to respond to requests. The application receives thousands of requests throughout the day. In the middle of the day, the application experiences 10 times more requests than at any other time of the day. Near the end of the day, the application's request volume decreases to 10% of its normal total. A DevOps engineer needs to reduce the latency of the Lambda function at all times of the day. Which solution will meet these requirements? A. Configure provisioned concurrency on the Lambda function with a concurrency value of 1. Delete the DAX cluster for the DynamoDB table. B. Configure reserved concurrency on the Lambda function with a concurrency value of 0. C. Configure provisioned concurrency on the Lambda function. Configure AWS application autoscaling on the Lambda function with provisioned concurrency values set to a minimum of 1 and a maximum of 100. D. Configure reserved concurrency on the Lambda function. Configure AWS application autoscaling on the API Gateway API with a reserved concurrency maximum value of 100. 3. A DevOps engineer manages a web application that runs on Amazon EC2 instances behind an application load balancer, ALB. The instances run in an EC2 auto-scaling group across multiple availability zones. The engineer needs to implement a deployment strategy that launches a second fleet of instances with the same capacity as the original fleet, maintains the original fleet unchanged while the second fleet is launched, transitions traffic to the second fleet when the second fleet is fully deployed. Terminates the original fleet automatically 1 hour after transition. Which solution will satisfy these requirements? A. Use an AWS CloudFormation template with a retention policy for the ALB set to 1 hour. Update the Amazon Route 53 record to reflect the new ALB. B. Use 2 AWS Elastic Beanstalk environments to perform a blue-green deployment from the original environment to the new one. Create an application version lifecycle policy to terminate the original environment in 1 hour. C. Use AWS Code Deploy with a deployment group configured with a blue-green deployment configuration. Select the option Terminate the original instances in the deployment group with a waiting period of 1 hour. D. Use AWS Elastic Beanstalk with the configuration set to immutable. Create an EB extension using the resources key that sets the deletion policy of the ALB to 1 hour, and deploy the application. 4. A DevOps engineer has automated a web service deployment by using AWS Code Pipeline with the following steps. 1. An AWS Code Build project compiles the deployment artifact and runs unit tests. 2. An AWS Code Deploy deployment group deploys the web service to Amazon EC2 instances in the staging environment. 3. A Code Deploy deployment group deploys the web service to EC2 instances in the production environment. The Quality Assurance (QA) team requests permission to inspect the build artifact before the deployment to the production environment occurs. The QA team wants to run an internal penetration testing tool to conduct manual tests. The tool will be invoked by a REST API call. Which combination of actions should the DevOps engineer take to fulfill this request? Choose 2. A. Insert a manual approval action between the test actions and deployment actions of the pipeline. B. Modify the buildspec.yml file for the compilation stage to require manual approval before completion. C. Update the code deploy deployment groups so that they require manual approval to proceed. D. Update the pipeline to directly call the REST API for the penetration testing tool. E. Update the pipeline to invoke an AWS Lambda function that calls the REST API for the penetration testing tool. 5. A company is hosting a web application in an AWS region. For disaster recovery purposes, a second region is being used as a standby. Disaster recovery requirements state that session data must be replicated between regions in near real time, and 1% of requests should route to the secondary region to continuously verify system functionality. Additionally, if there is a disruption in service in the main region, traffic should be automatically routed to the secondary region, and the secondary region must be able to scale up to handle all traffic. How should a DevOps engineer meet these requirements? A. In both regions, deploy the application on AWS Elastic Beanstalk and use Amazon DynamoDB global tables for session data. Use an Amazon Route 53 weighted routing policy with health checks to distribute the traffic across the regions. B. In both regions, launch the application in auto-scaling groups and use DynamoDB for session data. Use a Route 53 failover routing policy with health checks to distribute the traffic across the regions. C. In both regions, deploy the application in AWS Lambda, exposed by Amazon API Gateway, and use Amazon RDS for PostgreSQL with cross-region replication for session data. Deploy the web application with client-side logic to call the API gateway directly. D. In both regions, launch the application in auto-scaling groups and use DynamoDB global tables for session data. Enable an Amazon CloudFront weighted distribution across regions. Point the Amazon Route 53 DNS record at the CloudFront distribution. 6. A company is using AWS Code Pipeline to automate its release pipeline. AWS Code Deploy is being used in the pipeline to deploy an application to Amazon Elastic Container Service, Amazon ECS, using the blue-green deployment model. The company wants to implement scripts to test the green version of the application before shifting traffic. These scripts will complete in 5 minutes or less. If errors are discovered during these tests, the application must be rolled back. Which strategy will meet these requirements? A. Add a stage to the code pipeline between the source and deploy stages. Use AWS Code Build to create a runtime environment and build commands in the build spec file to invoke test scripts. If errors are found, use the oz deploy stop deployment command to stop the deployment. B. Add a stage to the code pipeline between the source and deploy stages. Use this stage to invoke an AWS Lambda function that will run the test scripts. If errors are found, use the oz deploy stop deployment command to stop the deployment. C. Add a hooks section to the code deploy app spec file. Use the after allow test traffic lifecycle event to invoke an AWS Lambda function to run the test scripts. If errors are found, exit the Lambda function with an error to initiate rollback. D. Add a hooks section to the code deploy app spec file. Use the after allow traffic lifecycle event to invoke the test scripts. If errors are found, use the oz deploy stop deployment CLI command to stop the deployment. 7. A company has a single AWS account that runs hundreds of Amazon EC2 instances in a single AWS region. New EC2 instances are launched and terminated each hour in the account. The account also includes existing EC2 instances that have been running for longer than a week. The company's security policy requires all running EC2 instances to use an EC2 instance profile. If an EC2 instance does not have an instance profile attached, the EC2 instance must use a default instance profile that has no IAM permissions assigned. A DevOps engineer reviews the account and discovers EC2 instances that are running without an instance profile. During the review, the DevOps engineer also observes that new EC2 instances are being launched without an instance profile. Which solution will ensure that an instance profile is attached to all existing and future EC2 instances in the region? A. Configure an Amazon Event Bridge rule that reacts to EC2 run instances API calls. Configure the rule to invoke an AWS Lambda function to attach the default instance profile to the EC2 instances. B. Configure the EC2 instance profile attached AWS config managed rule with a trigger type of configuration changes. Configure an automatic remediation action that invokes an AWS Systems Manager automation runbook to attach the default instance profile to the EC2 instances. C. Configure an Amazon Event Bridge rule that reacts to EC2 Start Instances API calls. Configure the rule to invoke an AWS Systems Manager automation runbook to attach the default instance profile to the EC2 instances. D. Configure the IAM role managed policy. Check AWS config managed rule with a trigger type of configuration changes. Configure an automatic remediation action that invokes an AWS Lambda function to attach the default instance profile to the EC2 instances. 8. A company must encrypt all AMIS that the company shares across accounts. A DevOps engineer has access to a source account where an unencrypted custom AMI has been built. The DevOps engineer also has access to a target account where an Amazon EC2 auto-scaling group will launch EC2 instances from the AMI. The DevOps engineer must share the AMI with the target account. The company has created an AWS Key Management Service, AWS KMS, key in the source account. Which additional steps should the DevOps engineer perform to meet the requirements? Choose 3. A. In the source account, copy the unencrypted AMI to an encrypted AMI. Specify the KMS key in the copy action. B. In the source account, copy the unencrypted AMI to an encrypted AMI. Specify the default Amazon Elastic Block Store, Amazon EBS, encryption key in the copy action. C. In the source account, create a KMS grant that delegates permissions to the auto-scaling group service linked role in the target account. D. In the source account, modify the key policy to give the target account permissions to create a grant. In the target account, create a KMS grant that delegates permissions to the auto-scaling group service linked role. E. In the source account, share the unencrypted AMI with the target account. F. In the source account, share the encrypted AMI with the target account. 9. A company requires that its internally facing web application be highly available. The architecture is made up of one Amazon EC2 web server instance and one NAT instance that provides outbound internet access for updates and accessing public data. Which combination of architecture adjustments should the company implement to achieve high availability? Choose 2. A. Add the NAT instance to an EC2 auto-scaling group that spans multiple availability zones. Update the route tables. B. Create additional EC2 instances spanning multiple availability zones. Add an application load balancer to split the load between them. C. Configure an application load balancer in front of the EC2 instance. Configure Amazon CloudWatch alarms to recover the EC2 instance upon host failure. D. Replace the NAT instance with a NAT gateway in each availability zone. Update the route tables. E. Replace the NAT instance with a NAT gateway that spans multiple availability zones. Update the route tables. 10. To run an application, a DevOps engineer launches an Amazon EC2 instance with public IP addresses in a public subnet. A user data script obtains the application artifacts and installs them on the instances upon launch. A change to the security classification of the application now requires the instances to run with no access to the Internet. While the instances launch successfully and show as healthy, the application does not seem to be installed. Which of the following should successfully install the application while complying with the new rule? A. Launch the instances in a public subnet with elastic IP addresses attached. Once the application is installed and running, run a script to disassociate the elastic IP addresses afterwards. B. Set up a NAT gateway. Deploy the EC2 instances to a private subnet. Update the private subnet's route table to use the NAT gateway as the default route. C. Publish the application artifacts to an Amazon S3 bucket and create a VPC endpoint for S3. Assign an IAM instance profile to the EC2 instances so they can read the application artifacts from the S3 bucket. D. Create a security group for the application instances and allow only outbound traffic to the artifact repository. Remove the security group rule once the install is complete.